This work presents a method to combine a high-level planner with low-level motion primitives in the context of daily living assistive robotics.
I will now fit the shoe to your foot.
The task of putting on a shoe is used as an example.
I can't see the shoe. Could you approach it to me?
Some low-level actions, such as approaching the shoe or approaching the foot, are kinesthetically taught to the robot.
I am picking the shoe from you.
A simple sequencing of these actions can fulfill the task if everything goes as expected.
Thank you for the shoe. I will now start the task. I am now going to approach the shoe to your foot. I will now fit the shoe to your foot. I am done. I will move away.
If anything goes wrong, this approach will likely fail. The high-level planner allows the robot to cope with unforeseen situations, such as the shoe being wrongly fitted.
I am picking the shoe from you.
Kinesthetically teaching all the scenarios would have been tiresome, if not unfeasible work. Thanks to the planner, it is possible to add some actions to ask or inform the user.
I will now fit the shoe to your foot.
By using adaptive low-level actions, complexity on the high-level planner side is reduced. Each action is demonstrated in several situations, such that the robot can learn the dependence between the movement and the situation. The robot is then able to generalize to a wide range of situations. In this work, adaptation with respect to both the shoe and the user's foot is considered. This adaptation is done by projecting the demonstrations in several coordinate systems linked to objects of interest, such as the shoe and the robot. The task is then learned in these different coordinate systems as separate experts. The combination of these experts through the product of their probabilities gives an adaptive model of the task.